Hey everybody, I just want to say welcome back to the notes. We're going to focus on angles. It's only one piece of paper, front and back, so the other side should have angle bisector and the front side should have angle. So we're going to start. Okay, so you probably have heard angles in other classes. So what an angle is formed by two rays. So remember when we took notes on opposite rays? Opposite rays have a common endpoint. So this is like an example of an opposite ray. An opposite ray make an angle. This common endpoint here that they share is called the vertex. And the side of the rays are called, the rays are called the sides. So if this is side AB and this is side BC of the angle. We name the angle by using the three letters where the middle letter represents the vertex. So when you read it and we say angle ABC, you're tracing it with your hand, okay? Using a single letter if there's only one angle located at the vertex. So we're going to see examples where you may have another angle that comes off of here, but you can't name it B because you don't know which one it means. So when referring to a measure of an angle, use a lowercase m. So if we were going to read this, it says the measure of angle ABC is equal to 60 degrees. So when we read it, you have angle ABC. It means you have your finger start at A, you go down to B, and you go to C. So it's that angle you're talking about. Okay. There are different types of angles. The first angle we're going to talk about is an acute angle. Okay, acute angles are less than 90 degrees. The next angle we have is an obtuse angle. These are greater than 90. And then we have a right angle. These are equal to 90. Gotta fix my focus. And then we have a straight angle. These are equal to 180 degrees. Okay, so a straight line equals 180. So what we're going to do is we're going to do the first example together. So we're going to name the vertex of this angle. So remember the vertex is where the two rays meet. So where do these two rays meet? They meet at K. Name the sides of the angle. So we need to name the two rays. So we have ray KJ. And remember you have to name it KJ because you start at its endpoint and then the point that goes on in one direction forever, and ray KL. Now we have to give three ways of naming this angle. So we learned that we can say the angle is where we list it by three letters. So we remember that the vertex has to be in the middle. So we can say LKJ. You can also read it the other way. So JKL. Or we can just say it is angle angle K, because there's no other angle that's there. And we want to classify this angle like for one of these up on the top. So if we were going to say, we can say like, all right, this is about a right angle, so it's greater than 90, so this is an obtuse angle. So if you want to stop the video and try to do this one on your own, that's fine, or just keep following along. What's the vertex? It is S. Name the three sides. We have angle ray RS, and we have ray, I named it wrong. I don't like how it gives you not a lot of space. So we have ray SR, because the reason why is because S is the start point. And then we have ST. Name three ways. We can say angle RST, angle TSR, or angle S. And this is a right angle because it is equal to 90 by this square here. So just like we talked about the other day about congruent sides, we can have congruent angles, which means they're angles that are the same. So if the measure of angle A is equal to the measure of angle B, then we can say the two angles are congruent. And that would be written as angle A is congruent. Remember, the congruent sign is that squiggle with the over the equal sign is equal to B. Okay? So looking over here, we have A and B are both 75 degrees. If you remember, we talked about segment bisector on the last notes. So this is an angle bisector. So it does the same thing. It cuts an angle in half. So a ray that divides an angle into two congruent angles in the diagram here, we have ray BD as an angle bisector. Therefore, angle ABD is congruent to angle DBC. And in this diagram here, we have this like arc. This is just denoting that these two angles are the same because their arc is the same distance from that vertex, okay? If we were going to name like a different angle, you can do them like with two arcs, but since these are both the same, they're going to have the same arc there, okay? Perpendicular lines are two lines that intersect at a right angle. So the symbol for perpendicular is an upside down T. So in this diagram here, we can say line L and line M are perpendicular. So we would write L is perpendicular to M. So a perpendicular bisector is like a perpendicular line where they make right angles, but we have the word bisector in here, so something's going to be cut into half. So a line segment array perpendicular to a segment at its midpoint. So in the diagram to the right, we have line LM is a perpendicular bisector to PQ. Okay, so that just means that these angles here are created at a right angle, and that P to this midpoint here is the same as that point to Q. Okay, so let's do some examples. So we want to write another name for angle CBF. Now we can't call this one B because are we referring to this angle here, this angle here, this angle here? We don't know. So we just have to name it another way. And to do so, we still have to keep B as a vertex because it's B in the middle because it's a vertex. So we can just easily flip it around. So we have angle FBC. Name the sides of EBD. So we have ray E, whoop, did it again, BE and ray ED. Right? Oh, B, did it again, BD. So BE and BD. We want to classify angle ABC. So ABC is a straight. It's a straight line, which is equal to 180 degrees. Give an example of an obtuse angle. So we want an angle that is greater than 90. So there's a couple here. I'm going to look at this angle, EBD, because it is greater than 90. Name two congruent angles. So we want two angles that have those arcs by them. So here's an arc and here's an arc. So we can say angle EBA is congruent to angle CBF. And name a perpendicular bisector. So we want to name something that cuts something into two right angles. So here's a right angle here, and this is also another right angle. So we know that angle our ray BD is the perpendicular bisector. Okay, last example on this page. What is the vertex of angle 2? So if we look at angle 2 here, the vertex is T. What is the vertex? Oh, name the sides of angle 4. So angle 4 is WTZ. So we have ray TW and ray TZ. Name another name for angle 3. So we can't name it T because we have all of these angles that share the same vertex, so we have to use the 3 letters. So it's ZTU. Write another name for angle 1. So again, we can't use T, so we can say YTX. Classify angle YTW. Well, that's a right angle because it has a square. YTU, that's an obtuse. And XTU, that's acute. And WTX is straight. And name 2 perpendicular bisectors. So we want to name 2 rays that would cut something in half. Or, I'm sorry, that make 2 right angles. So we have YT. And we also have, ooh, why did I put an angle? We'd also have ray TZ. And I also named this one again wrong. It's supposed to be TY. And lastly, name an angle bisector, so something that cut an angle in half. So here are the 2 equal angles, 2 and 3. T, you cut it in half. Okay, hope that video helped. See you later.